Homework 15, Properties of Logarithms, Video 4, Condensing a Logarithmic Expression. In the previous two videos, we discussed ways to take a single logarithm and expand it into multiple logarithms with the goal of minimizing the arguments, making the arguments as small as possible. But it's also a thing to completely reverse that. Condensing a logarithm is when you use the product, quotient, and power rules to rewrite a sum or difference, or both, of multiple logarithms into a single log. So it's almost like an accordion. Expanding is when it's compressed and you expand it into a longer expression. Condensing is when it's already expanded and you try to compress it back down. Basically, we just reverse the process and we still use the rules. For example, let's take a look at this one, condense. This is a completely numerical problem. 3 times log base 2 of 5 plus 2 times log base 2 of 3. Now you may be tempted to try to evaluate both of these logarithms. I will tell you right now, they are not whole numbers, they are irrational. What power turns 2 into 5? Some ugly decimal power. What power turns 2 into 3? Some ugly decimal power. But my goal isn't to evaluate, it's to condense. Now, when you're doing the properties in reverse, the rules in reverse, you have to think about the consequence of the rule happening already. For example, when the power rule happens, a number comes down in front, and we have numbers in front. So at some point, we're going to have to reverse the power rule. And when the product rule happens, you end up with a sum of logs, and we have a sum of logs, so we're going to have to reverse the product rule as well. But which one do we do first? Well, I can't use the product rule yet, because the product rule says when you have the sum of 2 logs, not the sum of 2 logs with numbers in front, but a log plus a log. So I have to fix the fact that there are coefficients before I can use the product rule. So I have to do the power rule first, so that these logs no longer have coefficients. And the power rule simply says if you have a coefficient, move it inside as a power. So the first log becomes log base 2 of 5 to the 3rd power. We could evaluate that, and we'll leave it alone just for a moment. And the second log says bring the 2 in as a power on the 3. So log base 2 of 3 to the 2nd power. And now we can use the product rule, because the product rule says the log of a product is the sum of logs, and backwards it says the sum of logs is the log of a product. So the product rule in reverse says make 1 log and multiply the arguments. 5 to the 3rd power times 3 to the 2nd power. Now if this were a homework question, I think they would expect you to actually work this part out. It's 125 times 9, which is 1,125. So log base 2 of 1,125. And now put it back into a single logarithm. So if you're good at expanding, just reverse the process and you're condensing. So let's try this next one. Condense 5 natural log of x minus 2/3 natural log of y. Let's think about it. Screaming power rule, because it already has coefficients which need to come back inside as powers. However, this is also screaming quotient rule, because the quotient rule says the log of a fraction equals a subtraction problem, and we have a subtraction problem. So we need to do the same thing we did before. Move the powers in first, so the 5 comes in as a power on the x inside the first natural log, and move the second power in on the y, so we get y to the 2/3 power. Now you might be thinking, am I going to have to rewrite this as a radical? Well, in the homework, I think it will accept it as a power, and I'm pretty sure it will accept it as a radical as well. So in the last move, as we do the quotient rule, I'm going to go ahead and rewrite this as a radical, but keep in mind the homework I think would accept it as a fraction power. Quotient rule says the log of a quotient equals the difference of 2 logs, so in reverse, the difference of 2 logs equals the log of a quotient. The positive logs argument goes on top, so x to the 5th on top. The negative logs argument goes on the bottom. I could write y to the 2/3. I could also write the cube root of y squared, using the rule for exponents about how to deal with fractional exponents. Both of them would be correct, whether you wrote this as the cube root of y squared or y to the 2/3 power. Now at this point, some of you are probably thinking, that's cute and all, but I don't need all that. I can do it in one move. Yeah, I agree. In the previous video, I showed you how to expand a logarithmic expression in one move by locating all of the factors on the top and the bottom, giving them all their own logs, dragging down their powers as necessary. Guys on top became positive logs, guys on bottom became negative logs. Well, you can completely reverse the process. If you are condensing a logarithmic expression and there is any subtraction problem, that means the quotient rule happened, which means there was a fraction. If these were all pluses, then it wouldn't be a fraction, it would be like the top one, where we just put them all together. But it's the presence of a single subtraction problem, much less two of them, that says this original log was the log of the fraction. Now, all I have to do is figure out what goes where. Positive logs arguments came from the numerator. This log is positive, its argument is x, but there's a 5 in front. Power rule says it's coming in as a fifth power. Now be careful. When you condense, you are turning it back into multiplication and division problems. I'm going to show you a common mistake and hope that you avoid it, or warn you of a common mistake. There's another log that's positive and it's this one. So it came from the numerator. So z plus 1 will go in the numerator with the 7th power. Now, here's the mistake people will make. But the logs were added, so I'll stick a plus here. Congratulations, you ruined a good answer. There is no rule that says what to do with the log of an addition problem. There is a rule that says a log turns into a sum of logs, but when you condense, you're putting it back into multiplication and division problems, not into addition and subtraction problems. So even though this said plus, this is not an addition sign. This plus is the sign that says it belongs on the top. Who belongs on the bottom? Logs whose arguments whose logs are negative. For example, this y is an argument of a negative log. So the y came from the bottom, but it had a 6th power on it. And this w minus 1 is the argument of a log that's negative. So the w minus 1 came from the denominator, and it had an 8th power in front of it. Same warning as before, don't fall into this trap. But it was subtracted, so I'll put a minus in front. You killed it. The minus tells you where the log came from, but at no point was it ever part of a subtraction problem inside the log. If you applied the quotient rule, yeah, it would pick up a subtraction, but when you put it back together, you don't keep the subtraction. So these condensing problems can be done in one move. You can get from here to here instantly. No subtraction problem, no fractions. Everybody get multiplied together with your correct powers. Oh, subtraction, there was a fraction. You go on top, you go on bottom. Pick up your correct powers. Subtraction, all right. You and you go on top because you're part of positive logs and you get your powers. You two go on the bottom because you're part of negative logs and pick up your powers as well. So this whole condensing and expanding can actually be done fairly quickly. The hardest part of the homework, in my opinion, is actually typing in the answer because you have to be very careful to type it in correctly. All right, I think that's all I'm going to show you on condensing, so we only have one more video left, which will finally answer the question, how do you put logs in a calculator when they're not base 10 and they're not base E?